Hello, are you able to hear me?
Yes, sir.
Why there are only 8 members?
Sir, CT session is also going on.
Yes, sir. The sessions are also there.
Then I will start the session. Today we're going to discuss about V. So first, we will see, these are the contents. Firstly, we will see what are random variables. And then what are the applications? And then we'll go to the discrete and continuous random variables. Random variables. R means random variables. And then we'll discuss about something known as probability, mass function, and graph of probability mass function. Probability mass function. And finally, we will see cumulative distribution function. Okay. These are the contents. Did I miss anything? Hello? Hello?
No,
Yes,
sir.
sir.
Then first we'll go to the first thing. What is random variable? First, I will tell you the definition, and then we will understand what the definition. Okay. Random variable is a function with domain as sample space. Sample space of an experiment and ranges real numbers. This this definition is very difficult to understand. But let us simplify this. For suppose there is an experiment. Listen this carefully. There is an experiment, and it has some sample space. Let us suppose dice, rolling a die, rolling a die. Rolling a die. What are the sample space? Sample space are like 1, 2, 3, 4, 5, 6. The function with domain as sample space. Domain means x this value. Sample space and range as real numbers. Now here the range is like real numbers. When x equal to 1, 2, 3, 4, 5, 6. Are you getting this? Hello? Hello?
Yes, sir.
Remember this. Now it depends upon the look. If you select rolling a die, then the event become this. The sample space will become this. Based upon the selection of the event or the experiment, the random variable changes. Now let us take other example. Now let us change the experiment. What are the experiment? Rolling 2 dice. Okay. Rolling 2 dice. rolling 2 days. And listen this carefully now. Xb random variable. Here x is the outcome. X is random variable. It represents sum of outcomes of 2 days. Okay. Now that means here the sample space is right. Look, there are two sample spaces. For die 1 it will be 1 2 3 4 5 6. For die 2 it will be 1 2 3 4 5 6. But they're not asking about this. They clearly defined as x as random variable which represents sum of outcomes of 2 days. So what is the sample space? Sample space gives us to. Can anyone tell what is the sample space?
It will be both the values of 1 1, 1 2, 1 3.
No, listen this carefully. What is the random variable?
It will be 2 to 30. Sorry, 12.
36, sir.
Look, x be a random variable. It represents sum of two outcomes. Sum of two outcomes of 2 days. Means 1 plus 1 is possible. 1 plus 2 is possible.
Yes, sir. I told that.
2, 3, 4, 4. Up to how many numbers? 36. Sorry, 12.
12.
6 plus 6, 12. 6 plus 6 is 12, sorry. Okay. 2, okay. This is the sample space. Are you getting this? This is the sample
Yes, sir.
space. Based upon your selection of random variable, you will get this. Okay. Now look at this definition. Now we will go to function with domain as sample space. Look here, sample space is like what someone said: 1 comma 1, 1 comma 2, up to 6 comma 6. Someone said this. Now you are
Yes, sir.
converting this whole thing. You are converting this whole thing into very simplest form. Something like 1 2 2 3 4 5 6 till 12. Okay, are you getting this? So we will select this based upon the sample. Clear, everyone? Hello?
Yeah, got it, sir.
Clear? These are the random variables. Like, this is the value of random variables. Value of random variables. Simply for better understanding, I will give you a summary. Input is sample space. Okay. But output is
Sum of the same.
output is value of random variable. For just understanding. Clear, everyone? Definition of this?
Sir,
Hello?
can you explain this definition, sir?
Look, function with
Last
domain. Look,
Yes, sir.
what is meant by domain? In maths, when you
Input
learned
in
about
sum.
domain,
Yes, sir.
input now. Look, domain and what is the range?
Range.
Range is the other thing. If this is the example, 1 1. If 1 1 is the domain, then 1 1 maps to 2. Agree?
Yes, sir.
1 plus
Addition.
1
Okay.
we selected.
Okay.
And then if 1 3, then it maps for 4.
It will be 4 4. Oh, okay.
Okay. Then 3 1 maps for
Okay.
4. Okay. Similar like this. Clear? You're
Yes, sir. So
converting
the
the
input
sample
is
space
input in the sample.
and output is the value of random variable. X.
Okay, sir.
Clear, everyone? Hello?
Yeah, clear.
So, sir, output is the sum of the domain. I'm confused.
No. Based on selection of it depends upon the selection of the random variable, isn't this?
Okay, sir.
Here I selected the random variable as sum of outcomes. Are you getting the point? Here I selected the random variable as sum of outcomes. If you select something other than this, then it may vary. Okay.
Okay.
Hello. It depends. Not always the sum.
Yes, sir. Okay.
Yeah. And then look, there will be some rules. There will be some rules we will discuss in the later part. Okay. Need to satisfy when you are defining a random variable. When you are defining random variable, there will be some rules it must satisfy. Okay. We will discuss it later. Okay. Now coming to the types of random variables. Random variables. Types. Discrete random variables. Discrete random variables. And continuous random variables.
Random.
Continuous. Now we'll discuss discrete random variables. Discrete random variables. Here, remember the range is discrete. How to always check? Range is discrete. When range is discrete, it is said to be discrete random variable. Okay.
So if domain is not discrete, we can call that discrete variable.
No. Look. Domain always, domain is sample space. Look,
Okay, sir.
domain is sample space. So most probably sample space is like, you can't decide sample space is like what is known as discrete or continuous. You can't, most probably you can decide, but we always go to range. For suppose if there is like if there are like some continuous distribution, if probability of a person reaching less than 11 minutes, if it
Yes, sir.
follows normal distribution.
Sir,
Yeah.
sorry to interrupt. There are actually two instructor sessions going on, sir. So what do we do now?
You will get recording now. You can, if just listen which is more important to you, and then you can present the other session in recording. Okay.
So can you explain what have you taught? What has been explained till now?
Just what is meant by definition of the random variable. Okay. I explained definition of the random variable. And then there will be some. Look.
So less
When you
than
draw
11
graph,
minutes means it will be
random
continuous.
variable. Look. When there is a, let us suppose there is a continuous distribution which is known as normal distribution. Here everything you play with areas. Like x, like if it is 11, if it is greater than 11, you'll find the area of this part. Because everything is possible. 11.1 minute is possible, everything is possible. So we always take range into consideration when coming to discrete or continuous random variables. We have to always select the
Sir,
probability of range.
So one more doubt, is the deadline
Yeah.
for week 9 today or on Friday?
I don't know.
It's 11.
I don't know.
It got extended.
So is the deadline today or on Friday?
It
Actually,
extended.
I don't know about that.
So
It's
because the
11.
deadline for all subjects shows 11, but only for statistics it shows 9. But we received an email, so
I think they forgot to update it. But you should have to submit it. All are same now.
Okay. Hello.
It's also updated for statics.
Just I'll continue the class. You have to select always range. For distinguishing between the continuous and discrete random variable. Because if you select sample space, it doesn't make sense because sample space always like it depends upon the experiment, but random variable depends upon your selection. Like okay, follow. And then we'll move on to the some examples. Like I'll teach you some examples. Want some examples. I already discussed about throwing the die. And then let's discuss some. What example can I discuss? First, suppose there are balls. I mean, like 3 black balls and 4 white balls. Now here, let x be a random variable. Which defines number of white balls picked, out of 5 out of 4 white. I mean like number of white balls picked out of 5 balls. Okay. Hello. Okay. Now, what are the possible values of x? Like what values can x take? Hello.
Into 1 by 5, 2 by 5.
0 to 4.
0 to 4. Okay. Here he said 5 balls selected. You have to select 5 balls. There are only total
Out
7
of
balls.
these 7.
Out of this 7.
Yes, sir.
Okay. So x can take 4 white balls, 3 white balls, 2 white balls, and 1 white ball. Agree? It can't take 0 because 0 plus 3 is only 3. Hello. Even it can't
Yes.
take 1 also.
And
1 plus 3 equal to 4. 5 is not satisfying. It can't take 1 and 0. Okay, clear? Hello. Are you getting
yes, sir.
this?
Yes, sir.
Yes,
4,
sir.
4 white balls plus 1 black ball. 3 white plus 2 black. 2 white, 3 black, 2 white plus 3 black. Okay, clear? This is the
Yes.
possible. Now you can find probability very easily by applying combination. Okay, clear everyone? Just I want to
Yes.
discuss about random variables.
Yes, sir.
Clear? Now here, this is represented as this is x. Like if you want to represent a probability of x, capital X equal to x means when random variable x equal to this value. For suppose if capital X is equal to 4, then it means that 4 white, I mean like 4 white balls are selected. 4 white balls selected out of 5 balls. Okay. Now coming to the x equal to 3. P of x equal to 3. 3 white balls selected out of 5 balls. Okay. You can all 3 white and 2 black. Okay. This is how you represent the probability. Okay. And coming to the most important thing, like okay, why you need this? Why we need this? why we need this? Why we need this random variable? Why we need to study about random variable? Can anyone have idea? Hello? Hello?
What, sir?
Hello?
Yeah,
Why we
we are
need to
listening.
study about random variable?
Yes, sir.
Why? Why we need to study about random variable?
So to simulate behavior of something in nature.
Okay, I will give you a hint. This is somewhat tricky. Listen carefully. For suppose there are three options for you. I think you know about policies. Life insurance policy. Life insurance policy. This is just an example. I mean, like policy one says premium equal to 30,000 per year and benefit after maturity is equal to uh, 30 lakhs. 30 lakhs. For suppose policy two says per year and benefit is equal to 20 lakhs. Policy three premium is 25,000 per year and benefit is 20 lakhs. Now listen this carefully. Here, this policy one is only given to 40, 46, and this policy is only given to, hello, are you able to hear me now?
It's
Hello?
still
Yes.
lagging.
Lagging. Just
Now it's okay. I think it's it's still lagging, sir.
The voice is breaking.
just wait. Are you able to hear me?
Yes.
Yes, sir.
Yeah, there is no lag now.
No, sir. No lagging.
Hello?
No.
Okay.
No lagging, sir.
20. Okay. This policy is only given to 20 to 40, and this policy is only given to 20 to 30. 30 years. 30 years is, and this policy is only given to 40 to 50 years is. Now look, if company want to know that, okay, on which policy does we have, I mean, like, does we get profit, on which type of policy we can get profit, more profit. How will they decide? Now listen this carefully. I mean, here I wrote maturity, but it is like death benefit after dying. Like policy comes after dying. So what happens? So there are only two outcomes. Like look, probability of a person like applied person dead is like somewhat 0.20 to 40. The probability of uh, the probability that person will live is more. Agree? Hello.
Yes, sir.
So for suppose there is like for 20 to 40 years people, and the probability of alive that they will alive this 20 years is like 0.7, and probability of death is like 0.3. Now listen this carefully. Now we can define a random variable. Defining random variable. Company's profit. Look, company will lost 30 lakhs if he dead. Company loses 30 lakh if he dead. So minus 30 to minus 30,000 will be, hello, are you able to see my screen?
Yes, sir.
Yes, sir.
Yes, sir.
Yes,
Hello?
sir.
Yeah, minus 30 lakhs will be one random variable. Agree? Hello. When
Yes.
and then company gains, how much company gains if 20 for 20, if the policy is paid for 20 years, 20 into 30,000 per year. So 20 years into 30,000 per year. Here it will be also. So 6 lakhs. Company will get 6 lakhs. Agree?
Yes.
Hello. So the probable, now look at this table. This is known as probability distribution table. 30 lakhs. What is the probability of death? 0.3. And 6 lakhs when it is like 0.7. Okay. This is x, and this is probability of x equal to small x. Clear? Now look, random variable helps us to find this. Like now there is something known as expectation that you will learn in next week. That means what is the expected amount that you will get. Okay, so you can find easily, like random variable makes your work very easy. Now you can easily tell that okay, I can expect, for suppose expectation is like, let us multiply these two and add, this is the expectation, minus into 0.3 plus 6 lakhs into 0.7. Don't worry, you will learn it in next week. Now what is the answer? Hello.
Okay, sir.
What is the answer?
Sir,
What is like minus 4,80,000. Now companies losing 4,80,000. Okay. Hello.
Yes, sir.
Are you getting
Yes.
this? Hello.
Yes.
Hello.
Yes. Yes, sir. We are listening.
Yeah. Did you understand what is the main purpose of random variable? You're converting all this numerical into some mathematical thing. You're doing some risk benefit analysis. You're calculating some risk and benefit. Okay. Clear, everyone? Are you getting this, or should I explain it more?
Yes, sir.
Yeah.
Clear, everyone?
Yes, sir. Clear.
So we can do the same thing with second policy, same thing with third policy, and you can find which one is okay. But you have to have this data is clearly, like I think what I took is like a wrong data, wrong probability, because it is, I mean, company is losing this much. Okay, clear everyone? Should I explain it again? Hello?
So can you just explain?
Yes, sir. Get it.
Yes, sir.
Just once, can you run through it quickly?
Okay, just look. Now you have three policies. Policy number 1 says 30,000. If you pay 30,000 per year, and if you pay till, I mean, like, if you can pay, I mean, like 20 years, and then if something happened, then you will take 30 lakhs. Okay. No, company losses. How much company losses? 30 lakhs if the person dies. Agree? Hello.
Yes.
Agree.
So here our aim is to see the profit of the company. See the profit of the company. Let X be the random variable which represent profit. I mean, so there are two cases. If person is alive, if the person is alive for 20 years, the company will receive how much? 20 into 30,000. 30,000 per year. That is 6 lakhs. Okay.
Yes.
If person dead, company has to pay
30
30
lakhs.
lakhs. It is minus because you selected it profit. It is not profit. It is loss to the company. Company is giving to the client. Okay. So now if you draw a table, minus 30 lakhs, the probability of company giving 30 lakhs is like 30%, 0.3. And the probability of company getting 6 lakhs is 0.7. Okay. Hello. Clear till now?
Yes, sir. Yes, sir.
Yes.
Now
Yes.
there are something known as expectation. How this is a, I mean, like, you will learn it in the next week. This expectation will help us to know how much money or how much profit that we can expect. It is just like mean. You can consider it as mean. It is a mean. So if you find mean, you are getting around minus 4,80,000. That is loss to the company. Loss to the company. So, like, listen this carefully. So with random variables, you can find the loss, and you can do, okay, which is I mean, we can compare 2 or 3 plans. Are you getting this?
Probably
These are the
fine.
applications of the random variables. Okay.
Okay.
Hello.
Okay.
Yes, sir.
Yes, sir.
Clear everyone?
Yes.
Yeah.
Clear, sir.
Can you just explain the last line?
Look, there is something known as expectation variance. These are like statistical tools that you can use for comparison to do, I mean, like, to do some to know data better. So this expectation is like, will help you to understand, like, what is the average getting. If someone asks you what is the expected profit, then it is like, what is the average profit. So if you find the expectation, you will learn it in week 9, week 10, don't worry. This expected value is like minus 4,80,000. Means company is losing minus 4,80,000 with a client, with every client. Okay, not with every client. On an average, company is losing 4,80,000. Okay. Hello. Still you didn't, I mean, like, you didn't get it. Hello.
Yes,
Got
sir.
it, sir.
Got it.
We got it, sir.
Okay. Then we'll move on to the next. Like, okay, now you have learned about this, like, random variable. Now there is something which is very important. You have to, I mean, like, you have to plot, like, I mean, like, this.
Sir, I want to ask something.
Yeah.
Sir, I'm just curious to know whether we need to know integration in order to solve the problems given in the graded assignment of week 9.
9. Integration.
Yes.
No, I mean, like, discrete. It is all, everything in week 9 is discrete. I think you don't need to know, like, because If there is some time left, I will explain. I mean, like, okay. Just don't
Okay,
worry.
sir. Thank you.
Now we'll discuss.
Sorry, sir, for disturbing.
Yeah.
Can I ask my doubt at the end of the session?
Yeah, you can.
Okay, sir.
Now we are going to the probability mass function. Probability mass function. Probability mass function. Mass means it is discrete. For discrete variables, it lies. And if it is PDF, probability distribution function, it is for continuous. Okay. Remember this carefully. Continuous function. Continuous random variable, not function. Continuous random variable, discrete random. Okay. Remember this very well. It is very, very important. Now, like, now let us.
PDF is for continuous random variable, sir.
Yeah, PDF. Probability distribution function. Probability distribution function. And probability mass function is for discrete random variables. Okay. Clear? Now we'll discuss properties of random variable. Properties of PMF. Properties of PMF. Look, sigma f of x of t equal to 1 if your
Sir, what is RV?
what is random variable, random variable.
Sir.
X belongs to capital T. So I used x now. Sorry, I don't want to use t. X. No, don't worry, I will simplify this. First of all, we'll take this example. The same example. Minus 30 lakhs. Then what is the 6 lakhs? And probability is 0.3 and 0.7. X equal to small x of x. X p of x equal to small x. Okay. Look, when you add these probabilities, adding probabilities must be equal to 1. Okay. Adding all the probabilities. Here 0.3 plus 0.7 gives 1. Hello.
Yes, sir,
Hello?
we are getting.
Yes, sir. Yes, sir.
Yeah. This is the most important thing, first thing. If there are like 100 random variables from x equal to 0, 1, 2 up to so on, there are like 100. And if there is some probabilities like this, probability like 1 by 3, 1 by 4, something like this. If someone asks you, I mean, like, what is the probability of x equal to x greater than
Sir, can you please
or
scroll
equal
up?
to 2?
Just a minute, sir.
Hello, sir.
Yeah. Hello.
Sir, in quiz 2, there was a question for which one of the options were quoted as wrong in the answer key. In the last session, we asked about it, and the teacher said she will check with the team. Is there any update available about it?
But what is the question?
In quiz 2, there was this question about a logo with 5 horizontal strips. And the answer that was given in the answer key was wrong. Where the team made aware of it, because in the last teaching assistant session, we tried to answer the question and the teacher also got the same answer as us. but the option given in the answer key was wrong.
No issue, then we'll sort it down, okay? No issue, just.
Sir,
Hello?
the result of quiz 2 will be when showcased on dashboard, sir.
Only like you will get to know, like most probably in 2 or 3 days, okay? Actually, you
Yeah.
Sir, if I am allowed to share the screen, I can show you the question.
Yeah, we already discussed about that, like. Okay, hello.
Okay, so
Hello, sir.
Hello. Yeah.
Hello, sir. When you are solving the quiz 2 questions, I have many doubts, sir.
Which two?
In quiz 2, yes, sir. Quiz 2 questions.
No, we are not solving quiz 2 now. We are not solving quiz 2. Already TS have took the session, I think, most probably quiz 2. Not
Oh,
solving
sir.
it.
Okay, sir. Thank. Okay.
yes, sir, in that session, one of the questions was wrong. So what is the
Yeah, we
update on it?
discussed that. How we discussed that? I think
So
they
we'll
gave the
get
mark.
the marks?
Like, answer is 328 something.
Oh.
Hello?
324 was the answer, but 528 was written as the answer in the answer key. So will marks be provided?
Yeah, marks will be provided.
Okay, okay. Thank you, sir. Okay, thank you.
Look, if someone asks what is the probability of x greater than or equal to 2?
Is 0. So we have to add all the probabilities from beginning from 2 till 100.
Yeah, 2 till 100. We have to add 2 till 100. But we don't know. But we know that adding all the probabilities is like 1. So 1 minus 1 by 3 plus 1 by 4, agree? Can we do like that?
Sorry, I'm not able to see the screen. Is there a problem my side?
Hello?
Yeah,
Sir, me
screen is
also
not
not
visible.
able to see your screen, sir.
Okay.
The screen is not visible.
Yeah.
Just wait. Okay, are you able to see this?
Screen is in not yet the.
Are you able to see this? Hello?
Yes, sir. Now it is.
Yeah, it is visible.
Now, if someone asks what is the probability of x greater than equal to 2, greater than or equal to 2, how will you find this?
We will minus the from 1.
Yeah. So
Of 0 or
it is
0
the sum of x equal to 2 plus sum of x equal to 3 up to so on p of x equal to 100, agree? So we don't know all these values, they didn't give us. So what we know is like 1 minus p of x equal to 0 plus p of x equal to 1, agree? So 1 minus 1 by 3 plus 1 by 4. It comes around 1 minus 7 by 12, 12 minus 7, 5 by 12. Clear, everyone? Hello?
Yes.
Yeah,
Now,
clear.
the second important thing is like, always the probability, you know this, like always the probability must be between 0 and 1. Probability of random variable. It is like p of x equal to x must be in between 0 and 1. Okay? This is all you know, like probability always lies between 0 and 1. Okay? Equal to. Okay, let us solve some examples. Okay? Clear, everyone, till here?
Yes, sir. Clear.
So what does f of x stand for?
F of x or p of x or p.
So the
This is
first
probability.
first statement.
This is probability, and I used f of x because it represents PMF, probability mass function. Are you getting the point? Probability mass function. Both are same. You can use p, but you have to specify that p represent probability mass function or fx represent probability mass function. Okay.
Yes, sir.
Okay. And then coming to the first, like we will solve one question. Let t be random variable -1, 1, 2, 4. Now fx of t equal to 0.5, 0.25, 0.125. Now, what is the value of f of x? Find the value of f of x t equal to f of x 4, f of x of 4, such that find the value of this.
Should add all and
Just find the value. I will explain after it. How you should
The
answer.
effect of what do we have to find?
4. Hello. We have to find
That's 0.125 the
0.125.
value. 0.125.
0.125. Yeah, exactly.
0.125.
Look, we know from the property like sigma f of x of t equal to 1. So 0.5 plus 0.25 plus 0.125 plus fx of 4 equal to 1. So fx of 4 equal to 1 minus 0.5 minus 0.25 minus 0.125. That is equal 0.125. Clear, everyone?
Sir, in the last
Now,
week 8 also, sir, we were minusing with 1. So what is that we should have to minus with 1 only, sir?
look, sum of probabilities will be always 1. Like, look,
Okay,
here
sir.
all the event, we are taking sample space of all the event. If we add the sample space of, like if we add all the possible events, it will again recreate the sample space. Are you getting the point?
Yeah.
That's why
Good.
it is coming as it will happen exactly.
It's
Something
like
like this.
100%.
Yeah, it will happen exactly. If all these are the possible random variables, remember this. If all these are the random variable, possible random variables. If you miss one random variable, then it won't make sense. Possible random variables. For suppose if there is a this rolling a dice. For suppose rolling a dice, only one die. There will be like random variables are like 6, 0, 1, 2, 3, 4, 5. 6, 0 won't be there, sir. This is the random variable. But if you skip 1, 6, only if you write only 5, and if you write 1 by 6, 1 by 6, these are the probability. If you add all this, you will only get 5 by 6. Are you getting the point? You have to add all the possible probabilities of the random variable, okay? You should not leave anyone. Hello? Hello?
Yes,
Hello?
sir.
Yes, sir.
Did you understand this?
Yes, sir.
Yes, sir.
And then moving on to the next question, like find p of x greater than 3.
Sir, it will be again 0.125.
Yeah, it will be 0.125. What is the only thing greater than 3? 4. So f of 4, okay? It is similarly equal to only thing greater than fx of 4. Now find this. Probability of x less than 3 by 2.
Is it 0.5?
No, not.
Okay.
So x of greater than equal to 3 means you have to consider x is equal to 3 also, right?
Not equal to, just I start.
Sir,
Yeah,
0.75.
yeah, 0.75. This is not equal to just. Now I will explain. Look, 3 by 2 means 1.5. 1.5. Now look, less than 1.5 means what does the 1 and minus 1 are there. 1 and minus 1 are there. Okay. So we have to add this. P of x equal to 1 plus P of x equal to minus 1. That equal to P of x less than 3 by 2. So what is the probability P of x equal to 1? 0.25 plus minus 1 P of x equal to minus 1, 0.5. So answer is 0.75. Okay. Clear everyone? Hello?
Yes, sir.
Yeah.
Sir, so P of x is equal to some value is equal to fx of that value, sir.
Yeah. If it is equal to, look, if P of x equal to 3 means fx of 3. Okay.
Okay, sir.
Then moving to the next question. This question is a little bit tricky. Given f of fx of k equal to c by 3 power k, where k starts from 1, 2, 3 up to so on, up to infinity. Now, what is the value of c such that fx of k be PMF, probability mass function? First, okay, and then find the value of P of x greater than 10. These are the two questions. First, find the first question.
Hello, sir.
Yeah.
So the value of C will be 2.
Value of c will be, yeah, near, yeah. Look, I'm solving this first question. Now they said c by 3 power k, where k is like 1, 2, 3 up to so on infinity. So what we will do is like, first let us substitute 0. These k values 3 power 1 plus c by 3 square, c by 3 cube up to so on till infinity. So take c common. 1 by 3 plus 1 by 3 square plus 1 by 3 cube up to infinity. This is known as infinite GP series. GP means geometric progression. So infinite GP, there is a formula like a by 1 minus r, where a is the first term and r is the ratio. Here first term is 1 by 3. 1 by 3 divided by 1 minus. To find ratio, divide these two. Second term divided by first term. Second r equal to second term is 1 by 3 square. And first term is 1 by 3. That equal to 1 by 9 into 3. That equal to 1 by 3. So 1 minus 1 by 3. C into 1 by 3 by 2 by 3. Okay. That equal to C by 2. Hello. C by
Yes,
2.
sir. Yes, sir.
So this is like some, I mean like sigma of fx of k. We know sigma of fx of k is 1. 1 equal to c by 2. C equal to 2. Clear everyone? Hello? Hello?
Yes,
Yeah.
sir.
Everyone got this?
Got, sir. I have got the same
Sigma
answer.
fx
Equal
of
to
k
2.
is equal to 1 is always mandatory, sir.
Yeah, it is always mandatory. When it look, when it is f, they give that fx of, this is like probability mass function, okay, or probability. Yeah, when they give it as like probability mass function. Okay, clear everyone? Should I explain it again?
Yes,
Sir,
1
can you
by
explain
Yes,
that infinite GP?
Look, infinite GP is like, look, for suppose, you know GP. GP means for 3 square, 3 cube, something like this. And then infinite GP means still infinite, like there is no stop. Look, R means second term divided by first term. 3 square divided by 3, that is equal to 3. Look, the formula for infinite GP is like a by 1 minus r if r less than 1. Look, here, if a by r minus 1 if r greater than 1. Leave about this certain thing. This is like a means first term. In this case, it is 1 by 3. And 1 minus r means second term by first term. 1 by 3 square divided by 1 by 3. That equal to 1 by 3. So 1 by 3. It is like 1 by 3 divided by 2 by 3. Equal to 1 by 2. Okay? Clear? Hello?
Yes,
Hello?
sir.
Did you get this?
Yeah.
Yes, sir.
Then this is the formula, like infinite. This a by, and ratio is nothing but ratio means r equal to second third divided by first term. Okay, and then we'll move on to the next question. P of x greater than 10. So the same thing. Here it is very easy. Look, we got the value c equal to 2. So fx of x equal to 2 by 3 power k, where k equal to 11, 12, 13, up to so on infinity. Agree? Hello? Hello? Did you get this? How? X greater than 10 means what is the possible? 11, 12, 13, 14, up to so on infinity. Okay?
Yes, sir.
So greater than 10 means we have to add all this. Fx of 11 plus fx of 12 up to so on till infinity. That equal to 2 power 2 by 3 power 11 plus 2 by 3 power 12 up to so on infinity. Okay, how will you find this? So
You find it for
take
up
2
to
by
10,
3 power.
then subtract from 1.
Okay, okay, that is a good thing, but I will do some other thing. Okay, let us take 3 power
Sure.
11 common. 3 power 11 common. 3 power 11 common. This is 2 by 3 power 11 common. 1 plus 1 by 3 plus 1 by 3 square up to so on infinity. Agree? Hello. Are you getting this?
Yes, sir. Yes,
Yes.
sir.
Look, I will explain. Look,
Yeah, you're taking the
this
common one, then you're trying to do have this one.
3
Okay.
square, 3 power
Then
12.
you'll go
This
for
can be written as 3 power 11 into 2 by 3. Sorry, 1 by 3. Okay, and then this is again infinite GP. A by 1 minus R. So we don't know R value. R equal to second term divided by first term. 1 by 3 divided by 1. It equal to 1 by 3. R equal to 1 by 3. So 2 by 3 power 11 into A by A means 1 here. First term 1 by 1 minus 1 by 3.
It will be
Equal
3
2
by
by
2, sir.
3 power 11. So 1 by 2 by 3. So 2 by 3 power 11 into 3 by 2. 2 will get cancelled. 3 by 3 power 11. That equal to, look, listen this carefully. Now 3 by 3 power 10 into 3. You can write like this: 3 power 11, 3 power 10 into 3. So I wrote it like this: 3 will get cancelled. 1 by 3 power 10. Clear? So P of x greater than 10 value is 1 by 3 power 10. Clear, everyone? Hello?
Yes, sir, clear.
Yes.
Sir, can you just scroll up little bit? Yes.
Yeah, can you scroll a little bit down? Got it. Thank you.
Then just try to do this question. P of x greater than 10 by x greater than 5.
That is it 1 by 3 to the power 5.
Yeah. I will explain. Look, here it is like P of A by B. That equal to P of A. What is the formula? A intersection B divided by P of B. Okay, this is the formula. So apply the same formula here in the top. P of x greater than 10 by x greater than 5 is equal to P of x greater than intersection x greater than 5 divided by P of x greater
So
than
it is the number of
Yes, sir.
words
Can-
which are greater than 10, probably greater than 10.
Now we will draw the 10 and 5. Okay. Now what I'm doing is like, sorry, I wrote 5 and 10. Look, greater than 5 means this side. Okay. Now I'm changing the color, red color. Greater than 10 means this. What is the common thing? Hello. Hello. What is the common thing? This is the common. Greater than 10 is common.
Yes, sir.
Okay. So it comes like P of x greater than 10, P of x greater than 5. Now in this, we already have the answer. P of x greater than 10. 1 by 3 power 10. But we don't have the answer of P of x greater than 5. Find this. If you find this answer, P of x greater than 5, will again come around the something like this. 2 of 3 power 5 plus 2 by 3 power 6 up to so on infinity. Agree? Now I'm taking 2 by 3 power 5 common. 1 plus 1 by 3, 1 by 3 square up to so on infinity. So 2 by 3 power 5.
Sir, if it is greater than
Yeah,
5,
but
then we have to consider from 3 to the power 6, no?
oh, okay, sorry, sorry, yeah.
Yes.
6. It comes like 6, 6, 7. Okay, count 6. Thank you for that. 7, 2 by 3 power 8, and then 1 by 1 by 3. 2 by 3 power 6 into 3 by 2. 3 by 3 power 6, that equal 3. 1 by 3 power 5. Okay, so it comes around 1 by 3 power 5. So what is the answer? Probability of x greater than 10 divided by x greater than 5 is equal to 1 by 3 power 10 divided by 1 by 3 power 5. So it is like 1 by 3 power 10 into 3 power 5 equal to 1 by 3 power 5. Okay, clear everyone? Hello?
Yes,
Hello?
sir. Yes.
Yeah. Now this is the example, and like I want to discuss. I covered most probably all the things, and like through this example. Let's see one practical example. Okay, let's see a practical, not a practical, but there is some application in this example. Okay. Question 2. Look, there is a lottery ticket. Lottery ticket. It is like three digit number. 3-digit. Look, if you win the lottery, you will get 2 lakh. 2 lakh rupees. Winning the lottery means like matching all the three digits. Okay. And then if they are, I mean, like the lottery offer is giving the offer, like, I mean, this lottery ticket seller is giving the offer that if ticket matches with 2 numbers, then you will win 20,000 rupees. Okay. And the third case, like, you will get nothing. I mean, like, there is only two possible cases. Okay. Now find the, he's asking like find the probability distribution of x, given that x is the profit and by the customer. Also given entry ticket for lottery is 5,000. Okay. Hello.
Yes, sir.
Hello?
Okay.
Yeah, fine.
So can you just read out the question once?
Look, lottery digit has 3-digit number. Like there are 2 cases, and entry ticket for lottery is like 5,000 rupees. Here, if
So can you please read out the question once? So can you please read out the question once? So can you please
I think we lost him.
Sir,
Can I read it?
read out the question once. Like,
May I read it for you?
yes, yes. Because I don't know what it really means.
It is written that there is a lottery ticket with a 3-digit number. If you win the lottery, then you will get 2 lakh rupees. And if the ticket matches with 2 numbers, then you will get 20,000 rupees. So you need to find the probability distribution of X, given that X is the profit earned by the customer. Also given entry ticket for lottery is 5,000 rupees.
Thanks a lot.
Okay, welcome.
Sir,
Hello, just wait. There is a power cut happen here. Just wait. Are you able to see my screen?
Yes, sir.
yes, sir. It's stuck.
Hello.
Yeah.
Hello.
Yes, sir.
Hello.
Sir.
Hello.
Yes, we can hear you.
Are you able to hear me?
Yes, yes.
Yeah. I can hear.
Yeah. Okay. Just I will start sharing the screen. Are you able to see my screen?
No.
No, sir.
Yeah.
Now, are you able to see my screen?
No, sir.
No,
No,
sir.
sir, not yet.
No.
Yes, sir.
Yeah. Are you able to see my screen?
Yeah.
Hello.
Yeah.
Yeah. Okay. This is the question.
Sir, are you speaking something?
Sir, your screen is not visible. It was stuck and now it's not at all coming.
Hello.
Yes, sir.
Yeah.
Yes, this is the question, master.
Yes, sir, visible.
Yes. Sir, are you speaking something?
No. Is there any disturbance?
No disturbance.
Just try to solve this question. Don't worry, I will solve this question.
Sir, means there is no how many percent ratio only, no, sir.
Why ratio? Look, I'm solving this question. Yeah. Now, how many person I'm like? In how many ways that a person can win
One way.
2 lakhs?
Two
Only
ways,
one
sir.
way.
Only one way.
Technically
No?
two.
How? Oh, no. This first case, through first case, 2 lakhs, winning 2 lakhs. Only one way.
One way, sir.
So
Only one.
now, just first thing, when there is a random variable question, study the random variable very well. Given that X is the profit earned by the customer, so X is profit. So X will get how much profit?
If it is a winner, then 1,95,000.
Yeah, look, X will get 2 lakhs if he is winner. But what is this? His investment is 5,000. So it is like 1,95,000. Okay, this is the possibility of one variable. And second thing is like 20,000 minus 5,000, 15,000. Agree?
Yes,
And
sir.
other possible
Yes.
for the random variable is like minus
It's minus
0.
5,000.
He will earn 0 rupees minus 5,000. That equal to minus 5,000. Okay, these are the
Either
three
of us,
possibilities.
when we do not win anything.
5,000, sir, but not 500.
Now 5,000. Okay. So here X takes 1,95,000
Sir, when do we get minus 5,000?
minus 5. If he didn't
we
win
don't win.
if you didn't win, but you spent 5,000 on that, there is no profit. Minus indicates loss.
Okay.
Loss of 5,000. Loss of 5,000. Now we need to find the probability. Look, there are like 3-digit number. Everything is repetitive. So first, like 1, 2, 3. First one can take 9 possibilities. The second is 10. 10. Total 9 into 10 into 10. That equal to 900. Okay. Hello.
Can you say again the 9, 10, 10? Sorry, I missed it.
Look. 3-digit. He said it is a
Sir?
3-digit type.
Sir?
Correct.
It is a 3-digit number.
Sir?
Hello.
Correct.
3-digit number. 3-digit
Correct.
number. So from this, first digit can take 9 digits. I mean, like, apart from 0, 1, 2, 3, 4 till 9. Okay.
Correct.
Second digit can take 10 possibilities. So third
Okay.
digit can take 10 possibilities. So total 9 into 10 into 10 possible numbers are possible. So 900 numbers are possible. Out of these 900 numbers, only one number is lottery number. So what is the probability? 1 by 900. Agree?
Yes.
Hello. So probability is 1 by 900. And secondly, coming 15,000 probability. Now listen this carefully. There are like 1, 2, 3 digits. And I'm changing the color. This is the lottery ticket number. Now, first two digits can match. The second case is like second 2 digits can match. And third case is like first and last digit can match. Agree? Hello.
It will
Yes,
be
sir.
like
Yes, sir.
10 into
So why
9
the
into
first
9.
digit can have only 9 numbers?
Because it is 3-digit number.
0 cannot be included.
Okay,
Yeah,
so
if it is 0, it is 99, it is 2-digit number. Okay.
Last few the
In some questions they will say that indirectly they won't say. In some questions they will say that the number starts with 0, 0, 0 and then it's 999. Okay.
Sir, we are.
Then you can take 0 in the first stage.
Sir, I have small doubt.
Yeah, you can ask.
So, sir, we are finding the probabilities guessing. Numbers can be guessed, but we don't know the probability who will guess the right now, sir. How much he will guess the
No,
right.
leave about that. Leave about that. We are not taking this. You're telling
Okay,
what is
sir.
the probability that winning of 1,95,000. Leave about who is winning. Who is winning is another course, not even this subject. Another course. Okay.
No, sir, I'm
That is
asking, sir.
statistics too.
Yeah. Okay.
Hello. Because this look, this is just how
How to win?
not even how to win. How
Means, sir,
how many
if
possibilities
we
are
want to
there?
win, we can have possible ways. Only
Yeah.
this, na, sir.
Look.
If you want
Yeah,
to win,
only this.
only
And then what is the way to win 1,95,000? What is the only way? Getting this number. That's all.
yes, sir.
Now, if you make this question more complex, the 500 students apply. I mean, 500 people apply. I mean, apply to this lottery or bought this lottery. Out of which 30% are very lucky. It will become very. I mean, like very complex. Then we have to find other ways. Okay.
Okay.
And then coming to now it is like selection of two numbers from three numbers. Okay, we have to select two numbers from three. That is 3C2. Okay. And the other thing is like, and one number is you can select anything like 9. Let me explain it here.
2 also
1, 2, 3. This is what? A lottery number. Lottery number. Select any 2 digits from the lottery number. 3C2. Okay. And then after selecting, what you have to do? There is a other one number is remaining.
So can you also interchange,
suppose-
sir? Yes, sir.
Yeah,
So
I will
can
explain that.
you-
No issue. Just wait. Just wait. I will tell. I will deal that case later. Just think this. If one number is remaining, how many, like, what are the possibilities of? I mean, like, what is the last number can take? Remaining
10
number can
or
take.
9. If it's middle, then 10, right?
Yeah. If it is first, it can only take 9.
Only first 9, sir, and later 2 numbers can take 10.
But we don't know what is this. I mean, like, what is the first or what is second? Like, are you getting this? We don't know this.
Yeah, got it.
How will you tackle this problem? How will you solve this problem?
Sir, we can go like by probability of first 2 and first and last and second and third.
Yeah, you have to break this. Look,
Or you fix something, once digit you fix it and try to move, find the
yeah,
probability.
look. You have to break this. 1, 2, 3. For suppose 1, 2 numbers are matched. First 2 numbers are matched. Look, listen, read this question carefully. If the ticket matches with 2 numbers, you'll get 20,000. But look, matching in the sense, listen this carefully. Matching means it must happen in order. Like, if the number is 325, then 320 they will give for 326 or 328 or 425 or 420, 525. Are you getting this? Hello?
Okay, sir.
Not like anything like any two. I mean, like 425 or something like that. Okay. So if 2 numbers are matching, then listen this carefully. First thing you have to do is, like, if first 2 numbers matches, so and then we can select last number in 10 possible ways. Clear till here?
Yes,
Hello?
sir.
Yes,
No.
sir. Can you please explain after the 3C2, what did you do?
No. If you follow this method, what happens is that you don't know which first thing or second thing is happened. Okay. Hello. You don't know this, so you should not use this method. Hello. Clear?
Yes,
Just for explanation, I'm using this. No, 10, and these 2 numbers are fixed. Okay. So 1 into 1. And the second case is like second. Again,
Okay, sir.
here it can only take 9. So 9 into 1 into 1. And third case is like first and last numbers are fixed. First and last cases are fixed. So here the possibilities are like 10. 10 into 1 into 1. Okay. Clear, everyone? So
Okay.
add all this. How many you got? 29.
29.
So probability is 29 by 1000. Sorry, 29 by 900. 29 by 900. Clear, everyone? Hello?
Yeah.
Yeah. No, look. Okay, now I am
why are-
arguing. Okay, in this, for suppose, there is, in these 3, there is a common thing.
Last number can have 10 possibilities, right?
Which number? Yeah, last number 10. 10 into 1 into 1. First number 9 into 1 into 1. Look, now I am arguing that, okay, in the first case, all these 3 numbers are 555. All these 3 numbers can be same numbers. Agree? All these 3 numbers can be same numbers. All these 3 numbers
Yes.
can be same numbers.
Okay, sir.
But what will, I mean, like, is it, look, you counter these as two extra numbers. Are you getting this? Hello?
Yes.
Are you getting what? Are you trying to understand what I'm telling?
Yes, sir.
In the first case, what happened is that, for suppose you consider 555. In the second case also you will get the 555. In the third case also you will get the 555. You agree?
Yes, sir. Agree.
Now,
Yes, sir.
what should we do? Hello, what should you do?
What difference it makes getting consecutive same numbers?
I'm not getting you.
Means why this concept, sir? Means anyway we can take it 29 by 900, sir. If we get
We can
continuous or
here look. Listen this question.
Here, probably can you say the problem again? See,
The
if we
problem
take
lies here. What happens is that if there are like you selected, look, you got 3 digits. 1, 2, 3 digits.
correct.
3 digits. For suppose first 2 digits are fixed. First 2 digits are fixed. And then you selected the third digit. And same thing, second 2 digits are fixed and you selected the first digit. And first and last digits are fixed and you selected the middle one. Okay. Now what I'm telling is that, look, there is a possibility that these 3 numbers can equal. 3 numbers can become equal. When
Right.
right, sir.
here, for suppose, let x be 5, 5, 5, 5, 5, 5. If you selected 5, 5, 5 here, these 3 are equal. 3 are equal. Agree?
Yes, sir.
Hello.
Then we have to divide it by 3 factorial.
Then divided by 3 factorial. Okay. Then if these are 6, 6, and it will become 6, 6, 6. How will you tackle this problem? Like,
Uh,
Sir,
yeah.
so sir, we can, if it was last number, we can get it by means 10. We can get in 10 different ways, no, sir. Like if it was first, there are 9 probabilities. Same like it is concept or different.
Now same concept. But my question is this: like 6, 6, 6. How will you avoid this? Are you getting this? 1, 1. If at all these two numbers are same. Okay.
All are
How will you,
same.
yeah, all are same. For suppose, look, listen this carefully. This happens only all numbers are same. All numbers are same. Because listen this. If it is like 345, for suppose 345 is the number. You fix 3, 4, and you fix 4, 5, and you fix 3, 5. Okay. So 1, 2,
Yes.
3. So if at all these 3 is the only possible thing, then it will happen. So what you will do is like do -2 here. That is enough. Okay. Are you getting this?
So can you just explain why the -2 is not a network issue?
Look. 3, 4, 5. First fix 3, 4. And leave 5.
So we can, there is
Four,
repetition
five.
allow
Leave
why
3.
we should.
Which one? Hello. And then fix 4 and here and here. Okay. This is what. Now listen this carefully. If the number is 333, all the 3 numbers are same, then you will get this problem. Are you getting this? The
see,
only possible that you will get the
Yes.
hello.
sorry to interrupt. See, 333 is a number from the lottery, right? So in that, we are
Yeah.
trying to check. Let us say my ticket is like having the first digit or last digit, or first two digit, or
Yeah,
last two, the 3, right?
Yeah.
So, okay. Then this.
What confusion is what difference it make we get same numbers? What matters differs from
Well,
not
we
getting the
ignore
same.
that other middle number, right? I need not to worry about, let's say in the first case, middle number, anything is okay.
Okay.
In second,
Anything is okay, but look, when for hypothetical case, if the lottery number is 333,
correct.
now look, however you select like 3, look, the only one possibility is like 10 here it is 10,
10.
here it is
Correct.
10. Okay, sorry,
So last
10
one
9
only 9.
okay, sorry,
Last
10
one is
10
9.
9, last one 9, here
Correct.
21. But the worst case is like, remember this, you have to subtract. Look, you got 333 three times. In the first attempt you got 333, the second attempt you got 333, the third attempt you got 333. You counted the 333 three times, so -3, and you have to add only one time. How are you getting this? 29 minus 3 plus 1. So 29 minus 3 is 26 plus 1, 27. Clear?
So that
Hello.
one, because there is only one possibility, right?
Yeah, there is only 1 333, not 3 333s. Why are you counting 3 times? Even if you count 3 times, the 333 only comes once. Hello.
They have to subtract
Are you getting this?
one, right?
Add 1, yeah. Clear?
Then
So sir,
become like no, for all the
we are
digits.
doing it for different times now, sir.
Different?
The possibility is we are doing for 3 different times now, sir. 333 can come.
Yeah, that's
three,
why
or
three different cases, but the number is same. That's why you have
Right.
to minus 3 plus 1. Okay, clear everyone? So there are like 27 possibilities. 27 possibilities, and then it is like 27 divided by 900. So it will come around 27 divided by 900, winning this 15,000. Now can anyone tell last?
Sir, I have a small query.
Yeah.
So the
Sir,
27 by 900 is for all 3 same numbers, no, sir?
Which one?
Only 2. The question was only for 2, no, sir. Or
Yeah, only for 2 numbers. If the selected thing, if the lottery has all the 3 numbers same, then it will happen like. Then it will happen. Okay.
We should have to minus it just.
Hello.
If there was if it was 3 numbers, it would be. If it was, sorry, there was 2 numbers, means we should have to minus 29 by 2, it will be 27, and we should have to add 1 or.
Look. Okay, this happens in here also. Look, for suppose here it is like 5 3 and then 4. Even it happens here also. Hello, are you getting this? You are counting the same here. Look, 345. So for suppose 345, first constant, make two numbers constant, 4 5 constant, and then 3 5 constant. Now if you select here 5, and if you select here 3, and if you select here 4, you will get 345 3 times. Are you getting this? Hello. Hello.
Yes, sir. Yes.
So that's why you have to. So what are the possibilities? 29 minus 3 plus 2. Okay. So 29 minus 3 is like 26 plus 2. 28.
Plus 1.
Okay. Oh, sorry. Plus 1. 27. That is the main thing.
So out of 3, we need only 1.
Talking about same number with respect to only 1, right? So it can happen for 1 also, 111, 222, 333, right? So there's a possibility for all the cases of 1 to 9. right?
Look, there are the possibilities of all the cases.
Correct.
But
So
making the
if
number
the
equal, like
question was
look, making this number equal is the case for us. Look,
correct.
For suppose 3, 4, 9. Tell me any number like 9, 4. I mean, like for suppose here you already fixed 4, 5 here. Here it is very look. You can make it equal to this number, not to any other number. Try. You can try this. Try on yourself. 3, 4. Here it is 5. Here 4, 5. And it is 3, 5. Now tell me any other number. Tell me any other number in this so that other than 3, 4, 5, it is possible. Can you form with this any three? You can try. It is not possible. Okay.
No. Yeah.
That's right. Clear, everyone?
for all three, the possibility is that 900 by 1 by 900. Means
This is
if
1 by
we select
900. First one is 1 by
first
900.
one.
This is
Means
27
all
by
three
900.
digits.
All three digits
Yes,
match.
okay.
And this is 2 digits match is 27 by 900. And finally is like 1 minus
sir,
1 by 900. Yeah.
If there was question like only one digit, if we guess is correct, it would be answer would be
This 1 by 900.
This 1 by 900.
Okay, one digit, only one digit.
only one digit, right? If
How
there is
for
two
minus
digit,
5,000? How is it 1 minus 1 by 900? Because
1 minus 1 by 900 minus 27 by 900. 27 by 900. Don't worry. This is total. Okay. Because everything must add up to 1. Okay. Clear? Hello?
yes,
Hello?
that one doubt, sir.
Yeah. What is your doubt?
What is your doubt?
If there was, if he matches only one number, also he can win. How many points there will be?
Matches with
many
one number means 1, 3. For suppose we will take 3, 4, 5 only. Look. I mean like first digit can be 3. Fix the first digit and other possible 10 into 10. 100 possibilities.
Right.
And fix the second digit like 6 the second digit 4, 9 into 10, 90. And fix the third digit 5. Then what are the possibilities? 9 into 10, 90. Okay. Clear? So 190 possibilities.
So 190 possibilities.
180.
180. Sorry, 180 possibilities. 180 possibilities. And then we have
It is 280 possibilities, sir.
No, look. 280 possibilities. And you have to subtract the same number, 3, 4, 4. Minus 2 plus 1. Not minus 2, I think this time. Let's suppose. Yeah, minus 2 plus 1.
Yeah, minus 2 plus.
Okay. Clear?
So why is it minus 2 this time?
Oh, okay. Minus 3, minus 3.
I think
minus 3 only.
minus
Right. Minus 300. Minus 3 plus 1. Same thing. Okay, clear?
Sir,
Yeah.
sir, like I have a doubt that
Yeah.
suppose if this kind of deep questions or like coming in the exam, like how we are supposed to approach this? Like as
No.
this is-
Actually, look. We teach this because you can see how how to think in this way. Okay. We won't ask this much deep questions, but we will break the question so that you will approach this. You know how we will ask these types of questions. First question is like find the probability when you wins the lottery. Like, probability of winning the lottery. Probability of winning the lottery. Second question we may ask like, okay, if suppose 555 is the winning number, we will indirectly give the hint. If all the three numbers are equal, we will indirectly give the hint. Okay. For most complex questions. Okay. Clear, everyone? We'll try to give hints, somewhat hint. Okay. No issue.
Okay.
Don't worry. Okay.
We'll move to next concept, sir.
Yeah. We'll move to the next concept. But what I covered here is like I covered applications, I covered random variables, and then discrete random. I will cover continuous random variable, don't worry. Now probability mass function, I have covered this, but I didn't cover the graph of PMF. For suppose I will take the simple example, very simple example. 2 dice. So x equal to 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What is the probability? 1 by 36? 1 by 36. What is the probability of 3?
3 would be
2 by
1,
36.
2, 1, 2 by
Hmm?
36.
2 by 36?
2 by 36.
3 by 36? 4 by 36? 2 by 36? 3 by 36?
5 by 36.
5 by 36? 5 by 36? 5 by 36? 6 by 36?
6 by
Okay.
36.
Now this is, now it comes like 1 by 36. Now if you want to draw plot like graph of PMF, like this one, random variables will be in x-axis and probability will be on the y-axis. Now look, here comes 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Now look, 1 by 36, it is somewhat here. And 2 is 2 by 36. And 4 is 3 by 36. 5 is 4 by 36. 6 is 5 by 36. 7 is 6 by 36. And 8 is again 5 by 36. 9 is again 4 by 36. Again, it is a 3 by 36. Here 2 by 36. 1 by 36. Look, you can see, look, you can know how the distribution looks like. Know how the distribution looks like. Whether it is looks like a, I mean like screw distribution, screw like it is like tending to one side or tending to, or it looks like a normal, or it looks like a
Symmetric distribution.
symmetric. Okay, you can see how the distribution looks like. Okay, this is the main advantage of this. Okay, screw distribution and symmetric distribution. Screwness is like whether it is shifting towards right or left, something like this. Okay, this is the main importance of what is this PMF graph. Okay, now there is something known as probability. Just wait. There is something known as cumulative distribution function. Related to distribution function. Cumulative means what? What is meant by cumulative?
Addition.
Yeah.
Adding
or it is like adding. It is like adding. Like if you have this same thing, if you have the same thing, like for suppose if you have the same thing, look, if there is a you have to add at every interval, like 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8, 8 to 9, 9 to 10, 10 to 11, and 11 to 12. Okay, you have to add at every interval so that you will get the cumulative distribution. Just I will give you an example. Now for suppose for easy understanding, let us take example which is tossing a coin. Tossing a coin, 2 coins, tossing 2 coins. What are the possible things? Head, head,
And
head,
then
tail,
tail head.
tail, head, tail, tail. 4 outcomes. Now we are counting X, we are random variable, we are counting number of heads. Number of heads can be 0, 1, or 2.
No, 0. No.
0 heads are
So
possible.
we
2
should
tails
have
means 0 heads.
sorry. Very close.
Yes. Okay. Number of heads. So 0 means 2 tails. Only 1 by 4 is the property. And 1 head means these 2. 1 by 2 is the property. And 1 by 4 is for two heads. Okay. This is the property. Now, if you want to draw, I mean, like, if you want this cumulative distribution function, cumulative distribution function.
So why not that one head is 1 by 2?
Look,
1 by
1 by
4.
4 plus 1 by 4. Head, tail, tail, head. So it is like 2 by 4, 1 by 2. Hello?
Sir, can you just scroll up a little bit? Yes.
Okay. Now listen this carefully. F of A, capital F of A is equal to, look, now first thing is like 0 to 1. If X less than 0, the probability is 0. Agree?
Agree, sir.
Hello.
Yes, sir.
And then if the next thing is like from 0 to 1. 0 to 1 there is a X. So X is less than 1 and greater than 0. Greater than or equal to 0. What is the probability? Less than 1 and greater than equal to 0 means 1 by 4. Yeah,
1 by
exactly.
4.
And then coming to X less than 2 and greater than or equal to 1.
3 by 4.
What?
1 by
3 by 4, the probability.
Okay, there are two answers coming. 1 by 2 and 3 by 4.
3 by 4 will be the answer.
Look, listen this carefully now. Here, X less than or equal to 1 and less than 2 and greater than less than or equal to 1.
We have to add 1 for y1.
So what happens? You have to add till here. Add till 1. Cumulative. Cumulative means add till that point. Add till that point. Okay, clear? Here, add till that point. Add till that point. Okay, till 1, not 2, because it is not equal to 2 now. Till 1 you have to add. 1 by 4 plus 1 by 2 is 3 by 4. Clear? Should I explain it again?
Sir, X is greater than or equal to 1, right? So the number of heads is greater than or equal to 1.
Oh yeah, greater than or equal to 1 and less than 2.
So it's only one condition that shows up, greater than or equal to 1. We can't consider 0 there, na?
Look, in cumulative distribution, look, you are talking about PMF. In PMF, you will do that. But in cumulative distribution, this is capital F means cumulative.
Okay, sir.
Cumulative distribution.
Sir, what's the
Cumulative
theoretical
distribution, you have to.
importance?
Yeah, I will discuss. Just wait.
So for cumulative, we have to take up to that number, is it?
Yeah, up to that, like up to that. Here 1,
Okay.
X is in between 1 and 2. So up to 1 you have to take, okay? And then X, what is the final thing? Hello?
1.
X is less than and equal to
X can take. So less
3
than or
by
equal
4
to
plus
2.
1 by 4.
X is less than and equal to 2 and the probability will be, and cumulative distribution will be 1.
Yeah. This final thing is 1. No, now you can look if you draw this
Greater than equal to 2, right? The fourth option.
4.
Fourth one
Hello?
has to be x greater than or equal to 2, right?
No. Less than or equal to 2, not greater than. If it is greater than, it is 0 again. 2 is the utmost value, so less than or equal to 2. Now look, 0, 1, 2. These are the I will take some distance.
Sir, shouldn't it be just equal to 2? Because less than 2 we have already done in all before
No,
cases.
you have to add. Look, you have to don't compare this cumulative function with what probability mass function, because less than 2 means you have to add till 2, like all the things till 2. Okay.
Okay.
Less than or equal to 2 means all the things less than 2, less than or equal to 2. Okay. So look at 0. What is the p of x? Hello. At 0, what is the p of x? Like x less than 0 means it is like 0. But x equal to 0, it is like 1 by 4. 1 till 1 by 4. Okay. Till 1 by 4. Now, and it continued till x equal to
1.
X equal to this. And at x equal to 1, it jumped to 3 by 4. 3 by 4 means till here. Okay. This is 3 by 4. But this is 1 by 2. Okay. Are you getting this?
Yes.
It jumped till 3 by 4, but it is 1 by 2. And then till it continued till x equal to 2. But suddenly at x equal to 2, it jumped till 1.
So, sir, according to the graph, the last one should be x equals to 2.
Yeah, x less than x equal to 2. Yeah, last one. Because the probability is become 1, like.
So it should be x only equal to 2, not less than equal to 2, right?
Look. This value continue till, like, you are adding till here now. Hello. Just wait, I'll confirm the just one.
Because sir, the graph we are making according to the x less than 0 equals 0, that we wrote. So it should be x equals to 2 when the probability.
X. Just wait. Here the correct notation is like x less than or equal to 2. Sorry. So the correct notation is x greater than or yeah. Look. Just don't worry. I will explain it. Look. It is continuing till. Just wait. I will erase all this. Just I will erase all this. Just this better. Just wait. Here, for suppose, this is a f of a. This is cumulative function. Cumulative function means you have to add till that point. Okay. First thing is like 0. I mean, like, first thing is this. When x, sorry, here there is a, so a less than 0. So it is like no probability, 0. Clear till now? Hello.
Yes, sir.
Now, listen this carefully now. Now, a can be in between 0 and 1. Agree? In between 0 and 1. Clear? Now, it is less than 0. So, you have to put equal to it. Now, what you have to do is like, till 0. Add the probabilities till 0. 1 by 4 plus 0 is 1 by 4. Okay. Now, second thing is like in between 2 and 1. Now add till 1. 1 by 4 plus 1 by 2. It comes like 3 by 4. Okay. Till here it is clear?
Yes, sir.
Hello. Now,
Yes.
last thing, listen this carefully. It is like, for suppose A. Now, if A is less than or equal to 2, we will add all this. Okay. But look, listen this carefully now. If A is greater than or equal to 2, for suppose A is greater than or equal to 2, the same one will follow. Because you are increasing it. You are increasing like, look, this is increasing order.
Yes, sir.
Increasing
So
order.
what is the
So even if
significance of
A greater
considering?
than 2, look, the significance is like, you will know till which value of random variable, I mean like, the event exists like, if it attain 1 at x is A equal to 2, then you can tell only 2 values are there. X can take only 2, 0, 1, 2. Okay, clear? Just I will explain it. Look, 0, 1, 2. First at 0, it jumped to 1 by 4. Okay, 1 by 4. And at 1, look, and it continued till here. But at 1, it jumped again to 3 by 4. It jumped to 3 by 4.
Repeat, sir, what are we currently doing? Because it's another class.
That if we add, how it will be 3 by 4, sir?
Look, 1 by 4 plus 1 by 2, what is the value?
1 by 4.
1 by 4 plus 1 by 2. 4,
It will be
2 plus
2
1,
by
3 by 4. 3 by 4. Hello?
Yes, sir.
It will be 3 by 4, sir.
Yeah. Look, and 3 by 4. If you subtract these two, 3 by 4 minus 1 by 4, it is 1 by 2. You are getting the probability of at 1. Are you understanding this?
Yes,
You are getting the probability. And then till 2, 3 by 4 continues. And at 2 exactly, it will become 1. 1 till here. It will become 1. And it will go till like after 2 also it will maintain 1 only. Now look, if you subtract these two, 3 by 4 minus 1, you will get 1 by 4. It is a problem. Look, the major purpose of this is like, you can see, okay, after 2, the probability is 1. So random variables possible are like x equal to 0, 1, 2. Or last random variable is 2. You can say that last random variable is 2. Clear? Hello?
Yes.
Are you getting this? Clear, everyone? Hello?
Yes, sir. Clear.
And you can observe this. What is this function called as? What is this function called as? Can you tell? Have you?
Step up function.
Yeah,
Nice.
this is step function. Step function. And these are good when this is known as step function. These are
Sir,
good when
what is
presenting.
that?
You can see how. Hello?
Sir, I didn't understood why we continued the function after 2.
Look, because you're adding till 2. I mean, like, are you getting this point? You are adding till 2.
Yes, sir.
If A is greater than 2, look, A is less than 2, it is 0. A is less than 0 means
0.
It is 0. Similarly, A is greater than 2 means that function already reached the probability 1 and it is continuing. Other this random variable, I mean, like, if A is greater than 2, it is not possible, but even though if A is greater than 2, it continues the same thing. Okay, similar like that. But we will stop. Here. A equal to 2, we will stop here. Okay, A equal to 2 or A equal to 3. But for mathematical notation, we will show this. Okay.
Okay, sir.
Clear everyone?
Sir,
Yeah.
Sir,
if A is less than 1, it's also always 0, sir.
A is less than 0, it's 0.
Is
Because
that less than 1?
A is less than, look. If A is less than 1, then you have to add only 1 by 4. A is less than 1 means 1 by 4.
0 is there, sir. My mistake.
Yeah, 1 by 4. And mathematically, look, I will tell you other definition like
One question about once it reaches 1 as a probability, why should we need to retain as it is?
can you repeat that?
Yeah, see, basically at the point 2, it reaches a probability as 1, right? Why the greater than 2, do we need to extend that line? Do we need to put it as
I mean, like, actually, this is like, look, cumulative function means, yeah, I mean, like, f of A is equal to probability of x less than or equal to A. For suppose, f of 2 means probability of x less than or equal to 2. At 2. For suppose f of 3 means, look, here 3 is not possible. So p of x of less than or equal to 3. But till 2 there is values. That's why we'll put it here. Are you getting this?
Yes. Got it.
That's why.
What are the
Nothing
maximum
more than that.
possible?
Mathematical.
It will carry the value.
Mathematical. Okay. Clear?
Thank you.
Okay, these are the contents that we will do one problem on. Because there is some. We'll do one
can
problem.
you please scroll up for a minute? So what have you done, sir? What is the question till which value of the random variable? The event
Till which value of random, look. If it is equal to, at 2, it is equal to 1. If A equal to 2, then if cumulative distribution f of 2 equal to 1, then you can stop here. Like, means you can
yes,
tell that 2 is the last random variable.
Okay, sir.
Okay. Or simply last random value. Last random variable. Okay.
Yes.
Then now just, I mean, like, now tell me the random, I mean, like, cumulative distribution of 1, 2, 3, 4, 1 by 4, 1 by 2, 1 by 8, 1 by 8. What is the cumulative distribution f of A? Tell me f of A. A less than 1. First is A less than 1. What is the value? 0.
0.
When A is less than 2 and greater than or equal to 1, what is the value?
1 by 4.
If A is less than 3 and greater than or equal to 2.
3 by 4.
3 by 4. And A is less than 4 and greater than or equal to 3.
7 by 8.
1 by 4. Are you
7
sure?
by 8.
Okay. 7 by 8. And then A is less than, look, no, after 4, look, 4 is the last thing. So what we will do is like, I'm using this carefully. A greater than or equal to 4. Equal to what is the value?
1.
1. Here at this position you can stop, like, I mean, like, because 4 is the value, I mean, f of 4 equal to, carefully, f of 4 is equal to 1. So you can say 4 is the last random variable. Okay, you can say. Clear? Hello.
Yes, sir.
Yes, sir. So sorry.
Okay, any questions?
How long is this class? Solve.
Yeah, this class is completed. Like you can leave. I'm like, I just if there are some questions, I will take the questions. Do you have any questions?
Yes, sir. I have doubt, sir.
Okay.
In exercise,
Which one? Number?
9.5, question number 1 and 3.
9.5.
I also have doubt in tutorial 1, sir.
Sir, will you share the slides, sir?
Yeah, I will share this first. Okay. What is the look? 9.5.
Question number 1 and 3.
Question number 1 and 3. Look, there are 3 red and 7 blue balls in a bag.
Yes,
That is
sir.
the
Yes,
question.
sir. Yes, sir. Right, sir.
3 red and 7 blue balls. 3 balls are randomly selected. 3 balls selected. Let x be a random variable. Let x be a number of red balls. Look, x means number of red balls. In 3 draw, I mean in 3 draws. In 3 draws. Which of the following is the correct probability mass function? Look, he said in 3 draws, like number of red balls in 3 draws. No, look, what are the possibilities of red ball? I mean, like number of red balls possible. What is the probabilities of x?
0, 1,
Yes,
2,
sir.
3.
How,
0,
sir?
1, 2, 3.
And 3.
Because look, number of red balls means red balls can be 3 red balls. There are 3 red balls. You can pick 3 red balls, or you can pick 2 red balls and 1 blue ball, and you
Yes.
can pick 1 red ball, and you can pick no red balls, all the blue balls. Okay.
Okay, sir.
Now in that question they didn't give. I mean, like with replacement or without replacement. With replacement
With replacement.
or without replacement. They didn't give that. So you have to check with replacement. Sorry, they gave
Yes,
with
sir. With
replacement.
replacement.
They gave with replacement. Means first look, first 0 balls means, listen this carefully. And 0 red balls, but 3 blue balls.
Yes, sir.
So selecting 3 blue balls means 7C3.
7.
Agree?
Yes, sir. I agree.
And then coming to the next one, 1 red, 2 blue.
Yes, sir.
3C1, 7C2.
Yes, sir.
2 red, 2 blue. 2C1, sorry, 3C2,
3, 7, 3, 2.
7C2.
Yes, sir. 7.
7C2.
See,
Okay.
yes.
Sorry, one blue ball.
Yes,
2
sir.
and 1.
Yes, sir.
7,
1,
7.
1.
So coming to the last thing, 3 red ball, 0 blue balls. 3C3. Okay.
Okay, sir.
Clear? If you do 70, look, and then it is probability. So we have to divide it by 10C3. Divide all this
10C3.
by
Yes, sir.
10C3. Okay, clear? If you find, you
Yes,
will
sir.
get the
Clear.
answer. Okay.
But I don't get the answer,
And then what is
sir.
the
You can do for x is equal to 0.
x equal to 0? Just 7 factorial divided by 4 factorial into 3 factorial. 7 into 6 into 5. Then 3 into 2, 6. 35 divided by 10 factorial by 7. 10 into 8. 10 into 9 into 8. Into 3 into 2. 2 3s. 2 4s. 120. It is coming 31.6. 34.3. Am I doing it right? With replacement or without replacement?
With replacement, sir.
1 by 1 with replacement.
In one row, we can take one ball, and when placed, then again take one ball, then keep it, and then take one ball.
Okay, just here we got wrong. Just wait. Understand this carefully. One by one is a, you have to be careful with this one by one, because look, first three I mean, like, first ball is like blue. First ball is blue means what is this? 7C1. Clear? Hello.
Yes, sir. Clear.
And then you replace it with again block, and secondly 7C1, and third one is 7C1, and divided by 10C1 into 10C1 into 10C1.
Oh.
Are you getting this? Now you will get.
No,
Okay?
sir. No, sir. How
You will
you
get,
find it?
because one by one means you pick one by one, one after one after one. Okay.
Okay, sir.
So you have to.
Oh,
You have to
we
first
can.
do one.
Yes.
So what is the
You will get
difference
it. Okay.
between the 7C3 and 7C1 into 7C1 into 7C1?
Look, actually, you won't find physically, but look, 7C3 means you're selecting three at a once. Selecting three at once means you're choosing. Now 7C1 means, listen this carefully. In the box there are 7. 1, 2, 3, 4, 5, 6, 7. You only choose one and you replace it with same thing. So what will happen? Again, there is a possibility of again 7 things, but here it is not like that. Here you pick all these three at once. Are you getting this? All these three at once, nothing more than that.
Yes, sir.
Hello. So
Yes, sir.
because look, and other difference is like, listen this carefully. Pick any three, it is not a problem. Pick any three, it's not a problem. Pick this group or this group or this group, it is not a problem. But here you are selecting individually, so it has more chances. Are you getting this? Here you are selecting individually, not a group.
Basically, it is 7 into 7 into 7. मतलब
Yeah,
वैसा वाला.
Yeah, 7 into 7 into 7. Yeah. Okay, but this creates some issue when without replacement, because first thing is 7C1, second thing will become 6C1, third thing will become
5C1. 5C1. Yes, sir.
No replacement is okay. Okay. And what is your doubt? Next doubt.
Yeah. Question number 3, sir. 9.5.
9.5. Question number 3. The answer coin is tossed price and distribution of the
From which question?
number of tails. 9.5.
Yes, sir. 9.5.
Look, listen this carefully. The unfair coin is tossed price and the distribution of the number of tails is given. Look,
Yes, sir.
look. Now what is he asking? If the coin is tossed once, then what is the probability that it will show head?
Yes, sir.
What is the head probability?
What is means unbiased coin? We can both side tail or maybe both side head.
No. First, look at the probability distribution function. What is that saying? Look, giving one. Look, 3 times. If a coin is traced 3 times, getting head.
Yes, sir.
Look, head has possibility of 0.027. That is equal to 2.7 percentage. Hello. And then
yes, sir.
What are getting one head? Sorry, one tail. One tail means 2 heads. 2 heads and tail head. Tail head. Sorry, tail head. Okay, agree? These are the only 3 possibilities. Yeah.
No, sir.
Getting 1 is like 0.189. That is equal to 18.9%. Now coming to getting two tails. Tail, tail, head. Tail, tail, head. Head, tail, tail. It is like 0.441 equal to 44.1%. And finally getting three tails. It is like 0.343. That equal 34.3%. Now if the same coin is only tossed once, it is tossed only once. What is the probability that it will show head? Generally, what? 1/2? Hello.
Yes, sir.
Getting three heads means getting three heads. What is the
Means
probability? 1/2 into 1/2 into 1/2. Agree?
Yes, sir.
Clear? So it is 1/8. What is
Yes,
the
sir.
1/8?
0.0. 1.5. Yes.
Now, look, getting three heads means again probability of head into if it is fair coin.
Yes, sir. It is
Probability of head
fair.
into
Fair.
probability of head into probability of head. Agree?
Yes, sir.
So that equal to probability of head whole cube equal to 0.027. Agree? So
Yes, sir. I agree.
probability of head
0.9.
equal to cube root of 0.027. That equal to 0.3. P of head. Clear? Hello.
Yes, sir.
Clear? Clear this?
Yes, sir. Clear.
Now, if someone asks what is the probability of tail? 1 minus 0.3, that equal to 0.7. Okay. Sometimes question, look, this is the answer now. You can check the question. Look, head tail means
Yes, sir.
0.3 into 0.3 into 0.7. What is the value?
Something 0.09.
0.063.
And into 3.
How it is, sir?
Look, there are three ways now. Getting two heads is in three ways. You will get the same, this 0.189 if you do this.
Yes, sir. 0.1.
Are you getting this?
Yes.
Clear?
Yes.
Did you get this?
Yes, sir.
Okay. Any other doubt?
No, sir.
Okay. I'm closing this session.
No, sir. No, sir. One doubt more, sir.
Okay.
Tutorial 1. Tutorial 1.
Tutorial 1. What is this? Okay. Can you tell the question?
I have to play video.
Okay. Uranium.
Yes, sir. Yes, sir. DK question type.
Yeah, look. Just wait a minute.
Sir, which question?
Tutorial 1.
Sir, can you share me the slide?
Okay, I will share. Look, I explained the same model question, but I will explain it again. No issue. Look. Uranium decays slowly by emptying alpha. The half-life cycle. The uranium probable pile of uranium. The probability of survival. They give f of k equal to c by 2 power k. Okay. Value of c. Now look, they didn't give k. I mean, like possible values of k. Possible values of k. They didn't give this. K can start at 0, 1, 2, 3, or k can start at 1, 2, 3. What will you take?
K belongs to 1, 2, 3, sir.
Read the question.
Where?
Hello.
It should be 0, 1, 2, 3.
Hello.
Yes, sir.
I'm not, look. Just see this. Like, read the question. They didn't give. They didn't give the k. K start from. K can start from 0, 1, 2, 3 or 1, 2, 3.
How, sir?
Hmm?
How?
Look. After k half lifetime. In question they give after k
Half-life.
half lifetimes. After k half lifetimes means what is the possibility? K can be 0, 1, 2, 3. 0 half lifetimes. Does the
Yes, sir.
it makes some sense. Okay.
Mm.
Okay. And then they also given that half lifetime is like 25,000 years.
Yes, sir. It means 25,000 later, the uranium atom left half.
Yeah. It will look for there is one. I mean, like 1 gram of uranium, it will become half gram. Okay.
Oh,
After 25 years. Okay.
Yes, sir.
Okay, clear?
Yes, sir, clear. Next, how solve it, sir?
What?
How to solve
Just
it, sir?
I told you one method. Like, what is the condition? It will be useful. I mean, like,
Hello,
what is the
sir.
condition? Yeah, hello.
Sir, can you explain activity question 9.4, question number 7?
I will look it. Just after I finish, I will go to that. Okay.
Okay, sir.
Look, they give after k half lifetimes. So it can be 1 half lifetime.
Yes, sir.
1 half lifetime. Or 2 half lifetime, 3 half lifetime. So k can take
1, 2, 3, 4.
1, 2, 3, 4. And then c by 2 power k. You know, sigma.
Sir, why can't K be 0?
Look, 0 half lifetime doesn't make any sense. 0 half lifetime.
Totally
Would
the
Doesn't make
be
any sense.
T equals
Because it is
0,
initial.
right?
What?
It means
It is,
initial stage now. So
yes,
it
sir.
makes sense.
Yeah, initial stage. Initial stage. But look, you are concentrating on this, like on these, like what is the decay? You can't like, so it is better to take from 1, 2, 3. Hello.
Okay, sir.
Okay, sir.
And then you can also see there is other method. Look, first half lifetime. First half lifetime. First let be a n be the number of, and then it is initially, but after n minus n by 2 power k. Agree?
Yes, sir.
And next what will happen? N minus n by 2 power k.
Yes, sir.
This will happen. So it happens like this. So what you can do is like you can compare. So first, I mean, 0 lifetime has no value. It is initial. So first lifetime has something.
Yes.
Look, something important. So k starts from 1. Like, so c, now sigma f of k is equal to c, take c common, 1 by 2 plus 1 by 2 square up to so on. See, it comes like, it is infinite AP, a by 1
Yes,
minus
sir.
r.
Yes, sir.
So c into 1 by 2 by 1 minus 1 by 2 equal to c. So 1, sigma f of k is 1. So c equal to 1. Agree?
Yes, sir.
Hello? So c equal, you will get c equal to 1.
Okay.
That is the main important thing. And then For the given value of C, find the probability of survival after 10 half-life times. Okay. K equal to 10 indirectly. You can simply substitute K equal to 10.
Yes, sir. Or C is equal to 1.
Yeah, C equal to 1. It is very easy. Okay.
Okay, sir. Thank you, sir.
Okay.
Hello, sir.
Yeah, someone. Yeah. This is the last doubt I will take.
9.4 question number 7.
9.4 question number 7. 9.4 question number 7. Look, a shipment has 20 similar computers. 20 computers. 20 similar computers. Where retail outlet containing 3 defective. Look, that means 3 defective and 17 perfect. Okay. If school makes a random purchase of 2 of these computers, find the probability mass function, the number. Look, X is number of defectives. Hello?
Yes, sir.
Hello?
Yes, sir.
Number of so X can take 0, 1 or 2. Okay.
Yes.
So for 0 defective means all company must select from these. I mean, like the school must select from these 17 perfect computers. 17C 2 divided by 20C2. Agree?
Yes.
And coming to one defective computer means 3C1 into 17C1. Okay, divided by 20C2. 2 defective computer means 3C2 divided by 20C2. Fine, you will get the answer. Okay.
So how did we get 17C2 here?
Look, 17 perfect computers. Out of 20, 3 defective, and there are 17 perfect computers.
Sir, hello, sir.
Yeah.
Sorry, the option, so the option number 1 is correct, but option 3 is correct.
17C2 will do that. Option 3.
Shouldn't they're asking us to select 3 computers?
3. No. Purchase of 2 of these computers. Only 2 computers are purchased.
Oh, sir. Okay, sir. 2 computers, but 3 are defectives. And X is equal to 0, 1, 2. What does it represent, sir?
0, 1, 2 is the defective, number of defective pieces. 0 defective, 1 defective, 2 defective pieces. Okay.
What about 3 defectives, sir? Shouldn't be included?
We only selected 2 computers. How can you include 3 defective? Yeah, both option A and C are same, man. Okay, 190. Sorry. There is 190 now. Only denominator just 5. No, option C is wrong. Hello.
Yes, sir.
Option C is wrong. Option A is correct. Just add all these 3. Look, 17 factorial divided by 15 factorial into 2 factorial. 17 into 16 divided by 2 divided by 20 into 19 divided by 2. 2 get cancelled. 17 into 16 is like 4, 5 is 4, 5 is 17 into 4, 68 divided by 5 into 19 is like 95. 68 by 95. It is correct. Option A is correct. Hello.
Oh, yes, sir. Yes, sir.
Okay, I'm closing this session now.
Okay.
Sir, please share the slides, sir. Hello, sir.
Okay, I will share the slides. Yeah, I will share the slides. Okay.